five, there are five rules. One rule is called, this is like for a current in a wire, in a straight wire, in a straight wire. So that is the right hand, right hand grip rule. And grip rule. That is this rule, that if this is the right hand grip rule, that if you're um, by gripping your wire with your right hand, so that your thumb points towards the conventional this thing, direction of the current, and then points in the same direction as the magnetic field line. So this is first. Then second is this is called for solenoid. This is also called the right hand grip rule, but for poles of the solenoid. This is for finding the poles. uh, Imagine gripping the coil with your right hand. Coil, now you're holding the coil with your right hand, so that your fingers point in the conventional direction. The fingers are pointing. Now see, the notice the difference. In the previous, the fingers were pointing in the field direction. Here the fingers are pointing in the current direction. There the thumb was pointing in the current direction, and the fingers were pointing. So the current was by the thumb, and the field was by fingers. Here current is by field, is the field, is the uh, fingers are the current, and the thumb is the pole. So the thumb points towards the north pole. So this is the other rule. So we have got another rule. We have got for current in solenoid. Current in solenoid, we have the right hand grip rule again. But here the fingers were giving the field, the thumb was the current. Here the fingers are the current, and the thumb is the north pole. So this is the right hand grip rule for poles. Right hand grip rule for poles. For poles. Then there are two more. This is for current in finding the magnetic field. This is for finding magnetic field. This is for finding poles. Then there are two more. There is one more which is called the clock rule. This is the clock rule. That means if you see from one end of the coil, if the current is moving anti-clockwise, the clock rule, anti-clockwise current gives north pole. Anti-clockwise is north pole, and clockwise is south pole. So that means if you see from this end, your coil, if the coil, the current, like here, the current is going, if you see the coil from here, the current is coming like this. So the current is coming from like this. That means this is the north pole. So you have seen the north pole here. And in the other side, the current will be moving like that. So it's moving called clockwise. So this is south pole. So this is S na S is like this is, see the direction, it is clockwise, and N is anti-clockwise. It is north pole. So this is the clock rule. Then there is Fleming's left hand rule. एक minute. Fleming's left hand rule and Fleming's right hand rule. So this Fleming's left hand rule is for finding force on a current carrying conductor, and this is for finding the induced current direction. So induced current direction. So I will show you one by one. If I see from this side, from this side, I will see this coil like that, this coil, and I will see the current going like this. So this is going in clockwise direction. Okay, it's going in clock, because this is south pole. And if I see from this side, supposing I see from here, I will see current coming like this. No, like it's coming like this. So it's actually, from this side, it was actually coming like this. So it's coming anti-clockwise. So this is north pole here. So from one side it will be south, from the other side it will be opposite direction. If you move your finger, it's moving clockwise in one direction. You see it from the other side, you'll see it will appear as coming anti-clockwise.